Hello everyone. Today we will talk about the hydrologic cycle and the groundwater movement. About 96 of water on Earth is seawater. Fresh water is only about 4% of the total water. Among freshwater resources, the glacier takes about 3% and the groundwater takes about 1%. The other remainders, such as water in the atmosphere, lakes, rivers, and the biosphere, in total is about 0.01%. Fresh water comes to the continent from precipitation. When precipitation hits the ground, some rainwater can infiltrate into the ground and recharge the groundwater. Most of the rainwater will run off the surface following gravity. The runoff the water will join rivers or lakes, which can charge the groundwater during droughts and be charged during the rain season. The sources of atmosphere moisture for precipitation is mainly from evaporation, which happens to the ocean and the continental surface water such as lakes, rivers, wetlands, and swamps. On continents, plants also draw waters from ground in a relatively quick way. Transpiration, it is a process that plants draw water to its body and lose the water through respiration. Precipitation, runoff, infiltration, evaporation, and transpiration are the processes that describe the hydrologic cycle. In this chapter, we're going to focus our discussion on groundwater and groundwater movements. First, I would like to introduce you some new concepts. Porosity. Porosity is a measure of void space in the rocks and is a fraction of volume of voids over the total volume between 0 and 1, or as a percentage between 0% and 100%. Grain size can influence the porosity. Between sandstone and shale, we can see that sandstone with a greater grain size has a larger porosity than the shale with a smaller grain size. Comparing well-sorted sandstone to poorly sorted sandstone with a smaller grain size, the porosity of well-sorted sandstone is greater. Comparing the sandstone with a cement to the one without, we find that cement can reduce porosity. Another concept is permeability. Permeability is an indicator of the ability for fluids to flow through rocks. High permeability will allow fluids to move rapidly through the rocks. Permeability is affected by the pressure in a rock. As the sediments bury to the deeper and deeper in a basin, the overload is greater and greater, so the pressure increases, and so the porosity and the permeability decrease. Another example, shale has a very small porosity and a low permeability. Fracturing shale can increase the porosity and more importantly, increase the permeability that helps the fluid flow in the shale, which is the engineering technique to extract the fossil fuel from shale. So, does the high porosity means the high permeability? Not necessarily. For example, limestone contains a lot of voids, but the voids are not connected, so limestone has a high porosity but low permeability. Groundwater can weather limestone and increase the porosity and the permeability of the limestone. In many places within a large mass of limestone, caves can be formed from groundwater chemical weathering. However, the more often cases are that groundwater chemical weathering increase the porosity of the limestone, but the small passages that groundwater flow and connect the voids can be easily cemented due to precipitation of new minerals. So the limestone generates So the limestone generally has a high porosity but low permeability. The next concept is groundwater table. The groundwater table is the upper limit of a saturated zone, below which the rock formations are all saturated with water, which is also called the phreatic zone. Above the groundwater table, the rock formations are not saturated and the water content fluctuates, which is also called the vadose zone. When groundwater table is higher than the surface of the ground, we can see the water on the surface of the ground, which are lakes and rivers, wetlands, or swamps. Where groundwater table is lower than the surface of the ground, it is a groundwater underground. Groundwater table is not stable. It rises during the rain season and lowers during the dry season. During the rainy season, surface runoff water contribute to the rivers and lakes. Infiltration of water charge the groundwater. The groundwater table rises and both shallow and deep wells can have water pumped out. During this time, when groundwater table high enough, it can recharge the river and the lakes. During the dry season, the groundwater table lowers. This time, the river and the lakes can recharge the groundwater. The groundwater flows from the river and the lakes to aquifers. Meanwhile, because of lowering the groundwater table, the shallow wells and even some of the deep wells cannot be pumped anymore. When the groundwater table is low, pumping deep wells can create a cone of depression in the groundwater table surrounding the well. This will affect the wells surrounded too, and it further lowers the groundwater table. This is the time that the rate of discharge of groundwater is greater than that of the recharge, so the groundwater table lowers. When the rain season comes, if the rate of recharge of groundwater is greater than that of the discharge, the groundwater table rises. When the usage of groundwater is large and always greater than that of the rate of recharge, the groundwater can be progressively depleted and we will be in a water crisis. Aquifers. Aquifers are porous and permeable rock formations that groundwater can flow through it underground. Usually, sandstone, gravels, and conglomerates are common aquifer rock. Sometimes, non-porous rock formations can be very good aquifer after fracturing, such as a fractured granite can be very good aquifer. Aquifers of sedimentary rocks has a more pore space but less permeability, while aquifers of a fractured granite has less pore space but more permeable. So the sedimentary aquifers can store more water, but the groundwater flows slowly in the aquifer. And this is the type of aquifer that provides a supply of water during the dry season for us. On the other hand, groundwater flows fast in aquifers of fractured granite, but the capacity of this type of aquifer is small. It helps transporting groundwater, but cannot store water for the usage during dry season. Aquifers can also be classified into confined aquifer and unconfined aquifers. Confined aquifers are aquifers below the land surface that is saturated with water, and the layers of impermeable rock formations are both above and below the aquifer. The impermeable rock formations are also called aquitars. This confined structure causes the aquifer to be under pressure, so that when the aquifer is penetrated by a well, the water will rise above the top of the aquifer. Unconfined aquifers are those into which water seeps from the ground surface directly above the aquifer. It is also where groundwater table fluctuates the most. Please watch the attached video. While watching, please also think about what are the controlling factors of the movement of groundwater.